I've shortened this up a little bit to try to help get us back on schedule. My name is Jacob Nelson. I'm from the University of Washington over in Seattle, where we have very similar weather to this right now, but it's a little bit colder. So I'm going to tell you about a benchmarking effort that that's been going on for a while now. Some of you may have heard about this a year ago. Unfortunately, the student who was working on it left, and so I'm trying to help nursemaid it along until we can find more resources to commit to it. Our motivation for doing this benchmarking effort is the system we've been building called GRAPPA, which is a runtime system implementing a variant of the distributed shared memory idea as a platform for implementing new analytics engines. And as we were developing this and trying to figure out what it needed to support, we ended up asking ourselves many questions. What sort of execution patterns do we need to support? What sort of other systems should we be comparing with? And looked out there and didn't see a lot of stuff. And so this is sort of an attempt at aggregating some of the data sets and some of the algorithms that we ended up implementing to do that comparison. So GraphBench. The idea here is to help out computer architects and systems researchers who are working at a very low level. So we want to support things that might be running on a single node in a cluster, might be running on multiple nodes in a cluster, might be even running on an accelerator somewhere on some sort of FPGA-based thing, which makes it much more challenging to provide some sort of set of reference implementations that actually make sense across all of these things. Our goal is to gather together simple graph kernels that could be implemented on all of these platforms, as well as data sets that can be used to evaluate these things. And we're trying to do this as a community effort. So we're throwing in some stuff. We have friends at CMU and at Berkeley who are also trying to contribute things. And of course, we're here taking advantage of the wonderful data generator from the social network benchmark. And so like I'm telling you, our approach here is not to take what is a more principled approach and to think about what sort of things we want to support in future systems and try to develop a workload for that, but simply to say there are a lot of people who are building these sort of low-level analytics engines today, projects like GRAPPA, like GraphLab, like Spark, like Ligra, like all of these things, and they're all using some set of graph algorithms to compare. So we just want to start by grabbing those and bundle them together so that we actually have a consistent set that we can talk about between these systems. We'd love to actually think more about where the choke points are in these things, but that's something that we're not doing at this point. And so the goal with that is to not just provide specification, the sort of paper benchmark approach that you see for a lot of things like this, where we're trying to support a diverse set of platforms. We're trying to make it easier to get started. So we're going to do two things there. First, we're going to link to existing implementations that are already in these platforms to help make it easier for people to compare. And when there aren't existing implementations, we'll write them and we'll include them in the repository that we have for this. And so we've aggregated a bunch of different implementations for a bunch of different kernels right now. And then the other thing that we're doing here, which I think is going to be really useful, is to make it easier to get started. So we're building Docker images for each of these systems for the set of kernels that we have here, so that maybe this isn't a platform on which you can immediately run experiments, but it's at least a platform that shows you how a properly configured framework looks, so that as you try to configure the thing on your cluster or on some other test system that you're working with, you have some sort of reference implementation there. So this is sort of a midpoint between the sort of all-inclusive experiment running framework that you might see in something like Spec CPU or Parsec, but it's a little bit more detailed than things you might see in like the problem-based benchmark suite or other paper benchmarks like that. So the interesting thing about this effort, especially in this community, is the question of data, because we know that for these graph kernels, the execution behavior can be wildly different depending on what type of data you give it. And so we've been trying to find real-world data sets that people often use to compare things, and to supplement that with synthetic data generators. And it's a little bit hard to see, unfortunately, in here what I'm talking about at the bottom. I'll see if I can fix that in a second. The challenge is that we want to be able to capture these effects that we only see in real-world data sets that we're not capturing with our synthetic generators. And I think that is the source of some of the efforts that we see here to improve those generators. Let's see if I can pull this up here so that I can. All right. There we go. Okay, well, I was hoping that would work, but I don't think it's going to. So that's a little bit easier to see. So the point here is that the common graph data sets, this Twitter snapshot from Keist and the Friendster snapshot that we see in the Snap data set, these are things that are used in all kinds of comparisons across all these different platforms, but they're tiny. When we're running on a 128 node cluster, we want to be able to take advantage of the whole 10 terabytes of aggregate DRAM across that cluster. These are data sets that in the simplest representation are 20, 30 gigabytes, something like that. And of course, that isn't the whole story. We want to be able to replicate things to mitigate hotspots and increase performance. But what's really interesting is to think about larger graphs. So for instance, the Laboratory for Web Algorithmics has done some work with this actual Facebook graph, which of course can't be distributed since it's internal to Facebook, but that's something like 137 billion edges, a couple orders of magnitude larger than these things that are available out in the wild. I know of only one data set out in the wild that's as large as that, and that's this Web Data Commons hyperlink graph at 128 billion edges. So there's a big disparity between what is easily available out there and what actually looks like real workloads, which I think makes it very difficult to have benchmarks that make sense. Okay. And so one solution to that is to generate our own data. And of course, that's what we're trying to do by using the social network benchmark dataset generator. So far, and this is largely due to my inexperience configuring Hadoop, we've been able to generate up to a scale 100. And that works great. And we're able to run on that. I have a couple suggestions. So the first thing is that to get to the point where we could actually generate data at that scale in a reasonable amount of time, we ended up switching a lot of the wonderfully rich data that is generated as part of the dataset generator, ended up switching that off. And Arnaud has been very helpful in making that work for us. So now we can just take advantage of the person knows person relation there. I'm sure there are lots of other relations. We as architects are fairly dumb about these things. We don't understand the use cases very well. You guys, I think, do. And so we're interested to hear more about what other interesting relations we should be looking at, what other questions we should be trying to model with these small kernels.
In these algorithms, do you have weights on the edges, or is it pure connectivity?
Yes.
There's versions. There's unweighted and weighted versions.
Right. So far, what the things that we've built so far are unweighted, but of course there should be things with weights.
Because natural thing that comes to mind is that you would give nose relationship a weight, and one way to determine that would be to see, and actually some queries do that, how much communication between two persons in terms of participation in each other's forums or messages sent to each other is there. And in that sense, it's not really realistic to say we don't want to see the messages in a social network like what's on the wall, because that's not the friends graph. Yeah, right. But in a real use case, actually most of the information is in that wall and in all those messages.
Right.
So yeah, a first step would be to determine the weights by counting how much traffic there has been in any kind of way, and then run the algorithm.
You have Twitter, you have follow relationship, which is what you would probably grab first, but what you care about is what people are saying. You extract some topics from that, and then you see how many times they're talking about those topics, and that could be weights. You can collapse the messages into weights from the edge, from the person to the topic.
Absolutely. And so then the question is, should we be taking advantage of the messages generated by the generator and doing that sort of counting ourselves in these benchmarks, or is that something that we could get you to do as a sort of add-on feature to the generator to give us the graph that we can then process? And there are trade-offs there.
From a good perspective, sure. we could do that for you. But if you think about a user, like somebody who has a lot of data, that user will probably start with that task. I mean, and if Grappa is a system that can run large algorithms over lots of data, then
Yeah, I mean, I could.
Sure, I'm just, the question is simply, do we want...
refuse to help him on that task?
No, but that's not the issue. The question is, do we want to include that counting process in this benchmark suite or not?
Yeah. Well,
And I think you could argue either way.
Well,
Right.
you would make it an extra task. I mean, it would be an ETL sort of stage before these others, and it would have a score of its own.
Right,
And
potentially.
then you would also consider likes, and you would consider all kinds of stuff like that. And you could have a fairly realistic, halfway complicated scoring function for different things, because that is very likely to occur in any kind of, let's say, marketing application or intelligence application. You would certainly have this sort of weighting of different forms of interaction, and these weights developing over time. Are they sustained? Are they just one-off? And so forth. So pretty much any application we can think of is going to have those behaviors, and putting them in a benchmark would not be a bad thing.
And this would take you away from just the graph benchmark into just an analytic benchmark, which then is a bit different and a bit more interesting, I would say, than just the graph benchmark. It's about full system workload. It's about ETL, the loading, the filtering, the aggregation, and then you got the graph. Run the
Absolutely. And I think there are a lot of interesting things to look at there, considering that, for instance, cache behavior, prefetch behavior is going to be radically different in the ETL stage than it is going to be in, running BFS or something like that. So, yes. So from that perspective, if we were to keep this as just a graph benchmark suite, as we've been targeting it, then it would be handy if the generator could actually just show us the data that we want to run our tiny little kernel on. There are, of course, reasons that it would be interesting to do something more complicated than that. And so the same thing comes up here. If we're just taking the output of the generator and running it, it would be handy to have support for generating output in some of the standard formats that you see in a whole bunch of these frameworks, like TSV. And this, of course, is completely trivial and is not really even worth a slide. It's just a matter of changing the, printf in the code. But for us, whatever, I don't care about this, but it might be something that would make the data more useful for other frameworks out there as well from the generator, beyond just your benchmark suite. The other thing is that, and again, I'm not really a Hadoop user, so it took me a while to get Hadoop configured on our box to the point where we could actually generate a data set of some reasonable size. And so I think something that could also help enable people to use the result of the generator here would be to pre-generate some data sets at different sizes and host them somewhere. And I'm sure that you could get somebody like Amazon to give you some space, give you lots of bandwidth.
This is a pretty good idea. And you can do it for free and have the user pay, whoever downloads the data set pay. And Amazon would love to do it, because if you use Amazon, then it's free, because you don't have to pay for downloading it. That's their model.
And this is a similar approach that's used by the Common Crawl, exactly.
That's what we're actually going to start using Amazon, because the Common Crawl is like 100 megabytes. It's going to cost us $16,000 to download it. That's how I could justify to Oracle that I had to use Amazon.
There you go.
$16,000.
And so the last suggestion here, and once again I will make my slide a little bit smaller so we can see it better, is a size question. So, again, the things that are out there in this sort of 1.4, 1.8 billion edge range, we'd like to get up to 128 billion edges. The scale 100 graph, as far as I understand it, is even smaller than that, right? And so it's, of course, possible to generate larger things, and I'm sure that with more configuration we will, but I don't know how well it's going to work to actually get up to this size here. Like, how long is that actually going to take to run?
Yeah, that's a good question.
Did it crash, or what did happen?
I mean, I'm either running out of memory or running out of disk space, depending on how things are configured. And if I finish reconfiguring my cluster to actually run Hadoop, then I may be able to run larger things. But I ask you guys, because you guys actually run this stuff. Whoops, and I've moved away from my slide there, because now we're...
What is the largest data set that was generated by folks here.
You know, but they look the largest ones.
One scale factor 1000 probably.
Only?
Yes, for the current version, yes.
Which is how many?
How much data is that?
How many
1
bil-
terabyte.
1 terabyte.
1
Yeah.
terabyte of data.
But that's
many
1
edges?
terabyte of everything, right?
The thing
How
is,
many
And so this is exactly the question.
if we disable
Friends
person
edges?
activity
How many just edges
generation,
total in the
we don't
graph?
know how far we can
Yep.
get. Because it's
Basically, you want to get to the 100 bill. You want to actually get to the trillion edge. That's
It probably already is that.
you think so?
I mean,
With 1 terabyte?
Like, I mean,
Well, it's not on show. Well, it's not on show.
Yeah.
no, the
Well, given that the scale, okay, so
Everybody has 50 friends, and
Yeah,
you have
well-
1,000 messages.
then they have 1,000. If you have 2 billion people, then everybody would have more than 500 friends, and then you would have the trillion range in edges at 2 billion people. Of course, these 2 billion people then might not have a very few or no messages because and no forums and none of that, because if that's the only thing you want, then that's what you want. And conceivably it could happen, but it hasn't been tried. What we try routinely on a single commodity box, you can make a 300 gig. It's going to take a couple of hours, and so, well, a terabyte is going to take maybe as much time on somewhat more hardware. And we'll be running during the term of the project on some small scale-out configurations up to 3 terabytes scales with the unmodified data set. If we wanted to do graph analytics, and we do want to do that, then it is true we will bias the data generation to make more friends and posts.
okay,
But there is no immediate answer to your question.
yeah,
Well, I think so. Just to also extend that, scale factor 1000 should be around 180 million. Because it says it's 3.6 million people times 50 friends in average.
It's more than 50, so it's going to be 100
oh,
or thereabouts.
average?
Average, yeah.
Okay, yeah, then it's 360.
There we are.
360 million edges?
Yeah.
That's smaller than Twitter, which is the smallest real data set.
and I don't, that's an ancient
That's 1000.
piece of Twitter too, so, yeah. Yeah, so, this may not be immediately in your interest, but I think it is an interesting question to see how we could support simulations and benchmarks at this
I
large
think the
scale.
pre-generated
Right.
idea is also,
Yeah.
we need to be green. How many people do we need to regenerate the huge scale factors, right? If we can get someone
Yeah.
like that, Amazon to give us the compute cycle to do it.
I mean, we have to see where we have a large cluster, we can easily then do these experiments.
Okay.
And certainly, things like the Kronecker generator will allow us to get to this scale in a reasonable amount of time, but of course that has its own problems. So good. And I think I will just stop there in the interest of getting us back on time. So, told you a little bit about GraphBench. Having a generator that generates interesting data is great, and I thank you for your suggestions, and we'll see how we can integrate them.
So did you, when running your kernels on the generated data, if you had some generated data that was on at the same level of other existing data, did you notice difference in runtime? Are you there yet?
No, not something we've actually spent any time looking at.
Okay.
Yeah, right now we're more focused on sort of filling out our tableau of benchmarks and systems.
Okay.
Good.
Anyone is using the data you generated. I think at the beginning you mentioned the data set can be used for like as an architect.
Yeah, I mean, this has been, we're trying to play a little game here, which is to say we already use some of this, of what we're doing here to tell us how to design our system, and we have friends working on other systems who've gone through the same sort of process, and so we're trying to basically take that process and give it a name, right? So that the next person who comes and starts working on some sort of distributed analytics runtime system can say, oh, I ran these set of kernels which are from this benchmark suite. So at this point, nobody's actually using anything that we've done here, but it's coming out of us having done this already. So.
I think what happens just says, actually not, the data set matters, but the data set plus the analytical algorithm implementation, I mean, matters.
Yeah.
If we just see one slide and it doesn't work. Actually, in my talk later, I will show you.
Uh-huh, great.
Can I just download the thing and just run it?
No. So here's the challenge with trying to assemble a collection of things like this. You've got Hadoop, you've got Spark, you've got GraphLab, you've got Grappa. All of these things have different runtime engines and under the hood, right? Built on top of very different system stacks. Some of them, I guess everything I talked about there is distributed. Many things are single node only. So the traditional approach for benchmark suites like this, where you can just download it and there's a script that you can run and say, run this set of experiments, doesn't work so well here. So what we're trying to do is build a set of Docker images, which are this container, Linux container thing, sort of halfway to a virtual machine, that contains some of this configuration so that we can at least get you half of the way there to being able to download and run experiments. You're still going to have to do configuration to get it to run on your cluster. We can probably build something that will just run on EC2. That's another thing that I'm hoping we will get to in the near future. So then you might be able to get some of that download and run, but in a particular cloud environment. But I think this is a really hard problem to find a reasonable way to compare against these radically different systems.
Well, it's because you're also taking on the role of doing the work that ostensibly should be done by GraphLab, Grappa.
Yeah.
All that. I think your
Well,
role should actually be more defining the kernels, defining, kind of the rules, and inviting those guys to say, well, go ahead and implement
Yeah.
me a script that I can set up your thing. Otherwise, then people won't be able to try your thing.
Sure. And I mean, what we're doing for the vast majority of those right now is just saying, hey, these guys have this kernel implemented here, and this is how you run it. These guys have this kernel implemented there. And it's just closing the gap between that set of instructions and an actual configured executable environment that we're hoping that we can provide some help with and get people in the community to work with. That's exactly what we're doing with Julian Shun at CMU with his system Ligra right now. Great. Anything else?
No.
Great.
Thanks, Jacob.
Thanks.